The first video lecture of electronic lab. In electronic circuit consisting of diode, transistor, MOSFET, we always need to provide sinusoidal waveform at the input. So that sinusoidal waveform can be generated with the help of function generator, and after generating the waveform can be displayed over cathode ray oscilloscope. So here let us begin with the study of function generator. This is our function generator device, and this is our CRO, that is cathode ray oscilloscope. So here, as you can see, 1000 Hz frequency range of sine waveform. As you can see, this is sine waveform and this is 1000 Hz frequency range, and also this sine waveform having 4.0 volt. So for your understanding, let me assure that the voltage range is introduced at y-axis and frequency range is introduced at x-axis, right? So this signal with the help of BNC cable. So BNC cable is basically connected at the output terminal of function generator, and the second end of BNC cable is connected to the input terminal of CRO. So basically this CRO having two different kind of channel. So I am basically connecting BNC cable to the channel 1. So as you can see, this is the sine waveform which is basically generated by function generator of 1000 Hz frequency range and 4.0 volt. So this range can also be calculated with the help of knobs which are provided here. As you can see, this knob is basically used to find out the voltage range which is basically mentioned at y-axis, fine, and this particular knob is basically used to find out the frequency range, and which is basically shown at x-axis, right? So let us understand how to calculate the values. As you can see, so this is the knob by which we can vary the signal corresponding to y-axis, and this is the knob by which we can vary the signal corresponding to x-axis. Now let me set this signal. As you can see, this signal having voltage range 4.0, right? So let me set it at 4.0 level, right? And I want to calculate the voltage range. So as you can see, this waveform from bottom to top, we need to calculate this waveform, and from bottom to top this waveform is covering 1, 2, 3, 4 full section, 4 full square, and also the 20% of this particular square, okay, 20% part of this particular square. So let me take value like 0.2. So ultimately after calculation 1, 2, 3, 4.2, and this 4.2 will be multiplied with this particular value which has been set at this particular by this particular knob. The value is 1 and the reading is in volt. So what we will pronounce it? We will pronounce it like 4.2 into 1, that is 4.2 volt. So as because of the noise, or we can say because of the disturbance, our waveform, while we are reading this waveform manually, we are getting 4.2 volt, but actually the 4 volt was produced with the help of function generator. So we can say that 0.2 volt error is coming, right? And also as you can see here, so let me shift it. Okay, fine. So if I want to calculate the frequency range, as you can see, the one cycle is going to complete in 2 full square. The one cycle is going to complete in 2 full square. So 2 will be multiplied directly with 0.5. So 2 into 0.5 will give you 1, and 1 is in millisecond. So 1 millisecond is the frequency, 1 millisecond is the time range actually, and that time range is inversely proportional to the frequency range. Okay, so 1 millisecond, as you are getting 1 millisecond, which is the time range, if you will write 1 by 1 millisecond, so it will give you 1 kilohertz. So as you can see, exactly the 1 kilohertz or 1000 hertz signal which has been produced with the help of function generator.